Today we're going to practice finding the slope of a line from 2 points. So let's get started. This video is going to be broken into 3 parts. First, I'll show you how I would solve a problem like this. Next, we will look at some things to consider when solving a problem like this. And then, as we've always done, we'll end with a practice problem so you can practice these skills on your own. In this example, we are told that a line passes through the points, and then we're given 2 points, 2 ordered pairs, -2, 4, and 3, 1. And we're asked to find the slope of this line. So if we know any 2 points that are on a line, we can find the slope of that line. And to find the slope of a line, I use the formula for a slope, which is m for slope equal to y sub 2 minus y sub 1 all over x of 2 minus x of 1. It doesn't matter which one of these points you consider point 1 or point 2. I typically have the first point be point 1 and the second point 2. That means -2 is x of 1 and 4 is y sub 1. So the x and y coordinate of the first point. 3 is x of 2 and 1 is y sub 2. So we'll plug these values into our formula for slope. So y sub 2 is 1 minus y sub 1 is 4 all over x of 2 is 3 minus, and then x of 1 is -2. And I will always write this out just to make sure I don't lose any negatives. So from here I'll do the arithmetic. 1 minus 4, that is -3. 3 minus a -2, well, this is 3 plus 2 minus a negative, that's addition. This is -3 over 5. Now you can leave the negative sign in the numerator, like I have here, so -3 over 5. But you can also write this with the negative in front of the fraction. So the answer to this question, our slope, is equal to -3/5. I'll go ahead and circle that answer. So let's take a look at this on a graph. So let's plot these points. We have -2, 4, and we have 3, 1. And we're asked to find the slope of the line that connects or passes through those 2 points. And we're looking for the slope of this line. So as a reminder, our slope, that's equal to the rise over the run. So that is the change in those y coordinates all over the change in the x coordinates. If we start at this first point, what's happening to the y coordinate between this first point and this second point? Well, that y coordinate is going down 1, 2, 3 units. So it has a change of -3. And then we do the same thing with this x coordinate. What's happening to the x coordinate as we move from one point to the other point? Again, we need to start at that same point. So we'll start with this leftmost point. And we go 1 unit, 2, 3, 4, 5. Went in the positive direction, 5. So our change in the y coordinate was -3. Change in the x coordinate was +5. That's the same value we got here. So when we look at slope, we're asking, how is this rise changing? How are the y coordinates changing as we move left or right on the graph? So in this case, as we move 5 units to the right, we drop 3 units. Now, one of the main things to point out is your selection of point 1 and point 2. It does not matter if you said -2, 4 was 0.1 and 3, 1 was 0.2. We could flip this. So let's say that negative 2, 4, that's now our second point. So this is x of 2, y sub 2. And then 3, 1, this is x of 1, y sub 1. When we plug this back into our equation, so we have y sub 2 minus y sub 1, that change in the y value, all over the change in the x value. So we now have 4 minus 1 all over negative 2 minus 3. We now have 3 over negative 5. We'll rewrite this as negative 3/5. We end up with the same value for the slope. Notice originally our numerator was negative and the denominator was positive. We have the opposite here. Our numerator is positive, the denominator is negative. But you end up with the same answer. What matters is this x of 2, y sub 2, this is from the same point. Let's see what happens if we grab the points wrong, if we set up this problem incorrectly. Again, we have a slope equal to y sub 2 minus y sub 1 all over x of 2 minus x of 1. And I'm going to say, okay, 1 is y sub 2. So that gives us 1 minus 4. Again, so for y sub 2, I picked 1. But if by mistake, instead of grabbing the 3 for x of 2, if I grab that negative 2, we now have negative 2 minus 3. So we grabbed the wrong coordinate when we were using this formula. We end up with negative 3 over negative 5, which is equal to 3/5. So when we do this, we end up with the same, absolute value of the number. So we ended up with the same fraction, 3/5, but our sign is incorrect because the sign of one of these arithmetic steps will be wrong because what we're subtracting is flipped. So everything's going to look okay, but your answer is going to be wrong. So make sure you're paying attention to what you're using for y sub 2, y sub 1, x of 2, and x of 1. Again, this is wrong. A great way to learn is practice on your own. We will discuss in a bit, but go ahead and pause your screen and do this problem. So what is the slope of the line that connects the points 5, 11 and negative 8, negative 15? So I labeled that first point as point 1. So it has an x-coordinate of x of 1 and a y-coordinate of y sub 1. And then the second point was point 2. So x of 2 is negative 8. And y sub 2, that y-coordinate for point 2, is negative 15. We're going to be using that slope formula. So the slope, m, is equal to y sub 2 minus y sub 1 all over x of 2 minus x of 1. Plugging those values in, we end up with negative 26 over negative 13. And that simplifies down to 2. But you could have also labeled 5, 11 as your second point, point 2. Negative 8, negative 15 as point 1. And then using this arrangement, you end up with positive 26 over positive 13, which also simplifies down to 2. So regardless of how you label your points, you should end up with the same value for the slope. In this case, the value of the slope is 2. Drop any questions you have in the comments. Continue practicing finding the slope of a line from 2 points, and I'll see you in the next video.